Hi, this is the second video looking at proportions in SPSS R Commander and R. This time we're looking at several independent samples of dichotomous variables. So here are our four groups. The first thing to notice is that the groups are independent. We have a smoker in group 1, but they can't be a smoker in group 2, 3 or 4. So we have four groups, smokers and non-smokers. Also, the groups might be different types of illness, different locations, anything, but one person only provides one bit of data to one of the groups. The next thing to notice is that the smoker-non-smoker variable is a nominal variable. We're not saying smokers are better than non-smokers, we're just classifying them as 1 or 2 in our data set. Importantly, there are only two categories in this variable. For either smokers or non-smokers, we're not classifying them as smokers, cigar smokers and pipe smokers. We're just having two categories which are called dichotomous or binary. The way that we analyse the data is we consider the actual values of the totals of each group. When we look at these groups totals by considering what's called the marginals. So we have the total of all smokers, which is 372, with the total of all non-smokers, which is 25, the total in group 1, which is 86, the total in group 2, 93, total in group 3, which is 135, total in group 4, 82, the grand total 397. So all those total values are called marginals. When we use these marginals, we can actually work out the overall proportion to be the average proportion if we just took the total value, which is 397, and then used either our smoker value or non-smoker value. So overall in our samples, all four taken together, we have a proportion of 6.3 non-smokers, and the overall proportion smokers is 93.7. If we assume that our four samples just display random variability in the proportions, we can say they all come from one population. And that one population obviously will have a proportion that we've defined here, this overall proportion, a 6.3%. or 93.7%, whichever way we're looking at the data. We have four groups of patients, designated 1, 2, 3, 4, each of which can be divided into smokers and non-smokers. Looking at the variable view, we can see how we've defined two types. 1 equals non-smoker, 2 equals smoker. We can also click here if we don't like to see the actual numbers. So we have in group 1, 83 smokers, 3 non-smokers. In group 2 we have 90 smokers and 3 non-smokers in the same. Remember that the k variable is basically our weighting variable. So the most important thing we must do is go to data, weight cases, data weight cases, and we want to weight them on the count variable. So we've chosen count and put it in here. Click OK, and now we have our counts as acting as a weighting variable. To get some idea of what the data looks like, I suggest you graph the data. So the graphs, legacy dialogues, bar chart, bar, that's graphs, legacy dialogues, bar. Click on there. Select the stacked version. We want summaries for groups of cases. Click define. Now we want to show the smokers versus the non-smokers. We want to show it for each group. So the category, that is for each column, we're going to have our four groups shown, but then we're going to divide them up into the smokers and non-smokers. Click OK, and here is our graph. Now, we can see that there's a very small proportion of non-smokers, which we have 4 groups. What would be nice is to compare them a little more clearly. So if you double click on the graph, then we select options, and the last item in the menu in options is scale to 100%. Click on that, and there we have the proportions within each group of non-smoker. So we can see in group 4 there's a much higher proportion of non-smokers compared to the other 3 groups. We don't know if this is statistically significant until we obviously run the test, but it's good to have some idea. What the test is doing basically is taking the average proportion and seeing if there is one or more group that varies significantly from this average. To carry out the analysis using the chi-square distribution, or actually a permutation test which works out all the possible values of this data set, we go to Analyze, Descriptive Statistics, Cross Tabs. Analyze Descriptive Statistics, Cross Tabs. Click on the Cross Tabs option, and then we select our rows as being the smoker variable and our columns being the group variable. It doesn't really matter which way around you do it. Now, we have several options here, options buttons. Let's look at the first one. Exact. We'll select the exact option here. This will give us an exact p-value rather than the asymptomatic chi-square value. Continue. Statistics. Well, we know we want the chi-square value, so we select that. Cells. Besides the observed value in each of the cells, we can also ask the expected value from our chi-square or our model that we're basing the chi-square on, or exact value. We can also ask for rows or column percentages or total percentages, which we've asked for here. We can ask for the deviation between the expected and observed, and we can ask for standardized version of that, just like linear regression. You click continue and then press OK. I've also asked it to display clustered bar charts just to see what it looks like. Here are the results. It's a good way to check that we've actually got the weighting variable working. There's 397 cases, which shows that it's not the 7 or 8 that we actually put in, which is good. And then we have the count for each cell. We have expected count based upon equal across all the 4 groups. That's what the expected value would be. That's the percentage downwards. And that's the residual. That's the difference between the expected and observed. So we can see that they are slightly less, but that one is much greater. So what we're saying is group 4 has many more non-smokers than we'd expect in it. It'll have less than expected smokers in it. And the results, the actual chi-square, are shown here. My PDF document describes which of the various exact p-values are important and how they vary. We can also have a quick look at the bar chart that was used, and you can see it's not really much use compared to the one we produced. It just shows that the percentage of smokers in each group are higher than non-smokers. In our commander, we can enter the data by using the contingency tables option. So it's statistics, contingency table, enter and analyze. Although it says a two-way table, we can actually cheat here. So we move the slider along columns, and we can have number of columns, we can have 4, number of rows, we can have 2. We go into the values here for each of our counts in the cell. So there are values for each of the cells. We'll ask for the percentage of the totals, and then we'll ask for the chi-square value, and also expected frequencies and Fisher's exact test. Click OK, and here are the results. So if you notice there, Fisher's exact test, we have a p-value of 0.01447, which is identical to SPSS. There are expected values, which again, if you look at the SPSS output, are the same. And there is a Pearson's chi-square test based on the chi-square distribution, which is exactly the same again as SPSS. In R, it is very simple to carry out the same type of analysis. We define a vector called smokers. There are 4 values in it. We use a concatenate operator to create the vector. Then we create another vector called patients. There are 4 values in it again. And then we just run a proportional test. Because there are more than one group of one portion, we can't answer a competence interval. If we do, we don't get anything. Talk about that later. So here we are, 4 sample tests for equality of proportions. That's a p-value of 0.005, and that's a chi-square value, and that gives a proportion in each of the 4 groups. Notice, as we said, the 4th group have much fewer smokers compared to the other 3 groups. So we've carried out the analysis in SPSS and R Commander. From our table that you can see the values for 4 groups above, we actually enter the data very differently in the 3 different statistical packages. In SPSS we had to use a grouping variable. In R Commander we used a simple dialog box and put the values in. And in our console, directly in R, we actually added the smokers vector and the patients vector, which was a total for each group. Another thing I'd like to mention was when we were looking at the output from SPSS, which we could also produce in R, which I didn't show you how to, and we looked at the standardized residuals, and we noticed that for group 4, the standardized residual was equal to 3. You could have accidentally interpreted that as being a count of more than 3 than expected. It's not, because it's standardized value, which is to do with the z-score equivalent. But also, these residuals are used to produce the p-value. Because remember, the p-value is related to the difference between expected and observed values for each of our groups. So obviously group 4 would have affected the p-value more than the other 3 groups, which deviated much less. What does this 3 value actually mean? Well, if we look at the normal standard distribution and what it relates to z-scores, remember that 99.7% of scores would occur within plus or minus 3 standard deviations. So if we look at our overall proportion, which we're talking about, which was 6.3%, that would be equivalent to a value of 0 on our standard normal distribution. So our standardized residual of 3 is referring to where that red arrow goes, which is way out. So we're saying that less than 0.03% of samples would have a proportion that's different from our 6.3% if they were just random samples from a population with a proportion of 6.3% of non-smoke, which makes sense, because if you look, we have in our 4th group 14.6% of non-smokers compared to 6.3%, which is over twice as many.